What's going on, guys? Lego Master 999-100 here. So I just got Universe Sandbox 2. So look at this. It's pretty dope just by looking at it. So what this app does is that, like, let's say if you're bored and you just want to play around with space, this is the app for you. Um, it's all about like messing things up around what will happen if you deploy this object, that object, or anything like, let's say VY Canis Majoris. What if you put it next to the solar system? Let's see. You're gonna see what will happen. So let's um let's play around with Earth. So you can see that it's about like 6,371 kilometers in diameter average. So luckily, not luckily, but unfortunately, they didn't make it oblate. So the equatorial diameter is not um 6,378.28, no, 0.14 more I'm more familiar with. So but anyways, let's get out any space object and actually get it to hit Earth. So let's see what will happen. Let's see if you get a relatively large object, such as, let's pull out Charon, or probably not, because I tried that before and then it started to become emitting this comet-like effect. So because it's an ice object. So yeah, that's why. So let's say if you get Ceres, also relatively large. So let's do this and let's just kill its velocity so it falls straight towards Earth. Let's get it to hit the Earth. Speeding up a little. There we go. Oh, oh, I almost said it. So you can see its shadow covering Kenya a little bit on Kenya and parts of Africa. So slowly getting there. So this is like over 100 times bigger than the asteroid that actually wiped out all the dinosaurs in 65 million years ago. So you can see there's a ring of fire. This would actually kill Earth's atmosphere at the size in real life, but in this game they decided to make the mass even bigger to actually maybe just so it's more fun for beginners. That's the thing, but they should make it more realistic than that. So this will definitely wipe out all life on Earth, because the asteroid that only hit that hit Earth, that annihilated the entire dinosaur race, is only about 10 kilometers in diameter. So how much more for this, for Ceres, even bigger. So we can see that there's a lot of cratering parts of Africa, parts of Middle East, parts of Asia, and a little in probably around near Athens, or yeah, and a little over here. I don't know where that is, but I know it's near Europe. So yeah, and this hit like near the geographic center. So yeah. So anyways, there's a lot of mini craters aside from the large crater. Look at this. This is this is like this is disastrous. You can see it's like from here. You can actually see the crater. Actually, you can see you can see that the Earth is not anymore round anymore, because you can see these little ridges over here due to the intensity of the impact. So let's turn up the time a bit so we can see how long it'll take to actually cool down. So it will take about, I don't know, maybe a few months or so. I, but it might be a little unrealistic because that should happen for years. But anyways, let's see what happens to Earth and see. Let's turn up the time. All right, now we just got rid of this tiny part in Africa, because you can see this huge crater. So the thing is, if you as you can see, uh, the water on Earth, it's been slightly reduced by a few kilometers because all the water is distributed throughout the crater. I mean the crater, and so a bit of it sunk into this. So chances are that the water level is going to decrease. So now you can see it's So let's see if we get a larger body and actually hit the Earth. Like, let's see, what if the Earth's moon actually hit the Earth? Oh, this is. I wonder what will happen if this happens. Kills the velocity. So, let's see what will happen. Oh, there you go. Oh my god. This is huge. Oh, that's glitched, but this is huge. Oh, look at all the water and everything. It looks more like a comet actually hitting the Earth. Wow, even just the fragments of the moon is equivalent to the one that actually hit over here. Wow, look at this. Look at this. Holy. This is huge. Maybe the Earth is just a little tripping over here. So it wouldn't go this bright. Let's turn the time up. Wow, this is getting even brighter. Looks like the Earth is tripping. Look at this. Wow. So let's check its climate. Like 1944 degrees Celsius. So this is hot. So let's wait for like a few decades to pass so we can actually cool this entire planet down. And now we just get this dead little planet over here. Wow, the terrain hasn't been changed since. But let's see if we get an even bigger body such as Mars. Oh wait, oh. And sometimes there's little bugs that we have to deal with in Universe Sandbox. So let's try that again. There's a huge bug there. That shouldn't happen. But anyways, it's a little buggy because Universe Sandbox is only in its alpha state. So that means they still got a long road ahead in order to do its official release. So let's turn up the time. Holy, this is huge. And now the Earth. No, this is not anymore tripping. So let's see its climate. Wow, this is like almost as hot as the sun. G2V. Wow, we just created another sun. How does this look? Another sun. Maybe a class K2V. No, maybe yeah. Let's say a K2V star, something like that. And then, but there's no fusion, so it wouldn't stay hot for long in astronomical scale. And there's a little bit of lighting defects, so it's cooling down. So it's 2049, and the Earth it's finally dead. Now it's starting to look more like a dead planet. Wow, what just happened? This is when Mars actually hit Earth. This was once a beautiful planet. That's what aliens would say, or yeah. We see everything's been destroyed. So the thing is, and wow, it looks like the orbit has been altered. Wow, the Earth's orbit has been altered. Can't believe it. Let's just turn this up so we can. Wow, the Earth's orbit has been altered so much. Wow, like it's heading towards the Martian orbit. So this is our new solar system once Mars has hit the Earth. So let's see if let's do something large scale. So let's see if we deploy stars such as VY Canis Majoris. That is like the largest known star. No, not the largest known star. Actually, the largest known star ever is UY Scuti. So let's deploy that instead. You can see if you compare the radius, 6.6 astronomical units, and if compared to US Scuddy, it's about 7.94 astronomical units. So it's way bigger than VY Canis Majoris. And if you look at this, wow, this is bright. So if you compare it, it'll extend towards the orbit, probably Saturn or Uranus. Yeah, let's say Saturn. So let's turn down its velocity to like 0, so it can actually head straight for the sun. So if you see the sun, look how small it is compared to UI Scuddy. So let's turn up the time frame. Wow, this is taking a long time. And here my computer, it's working a lot. Well, all the planets have been like sucked up. It's acting like a giant black hole, but actually its density is too low for that. So let's let's turn down the time frame. It's just too fast. So you can see that let's wow. It's engulfing everything. So Ceres has been engulfed. Oh, the sun has been engulfed. The sun has been engulfed. So let's see what'll happen. Holy, whoa, what just happened here? What just happened here? Alright, so here's another bug. Like, in order to actually turn into a planetary nebula or supernova, then the thing is, the mass has to be, in Universe Sandbox, the mass has to be over 1.274 something solar masses to actually do this. This is totally unrealistic. Because in real life, in order to turn to there are some stars that are over 2 solar masses, and yet they're still in their main sequence, and when they die they turn into a planetary nebula, no matter what. So they should actually change its supernova mass to about like 10 solar masses, because that's the minimum. That's like usually around like the average minimum mass to actually go supernova. So this is one of the major not bugs, but one of the errors that I noticed. So if you turn up the time scale to, let's say, years per second, so we're going 62 years per second. So see, the nebula is actually increasing so much. Wow, this is getting huge. And now the nebula is gone after 40 millenniums. And if you put it to 1 year a second, you can see that UI Scuddy is saying ha 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 ha. I just engulfed the entire solar system, and wow, look at this. This is when the asteroid and the Kuiper Belt has been destroyed. We have this little cloud over here, with Neptune being so far from the US Scuddy that it's just really cold. Let's see its temperature. Wow, almost absolute 0. And let's check Uranus. Oh no, Saturn. Wow, this has been wow. Wow, everything's destroyed. Its temperature is like almost absolute 0. So anyways, that was pretty cool. So let's try doing some more stuff. Like, let's say if you smash smash Saturn to Jupiter. Let's see what will happen if you do that. So now we just have to reset the entire simulation. So now let's turn this down to like about like say real time, second a second. Always it's always good to do that. So no, let's do Jupiter. So and of course Jupiter has rings. So let's see if we could like put a ring system around Jupiter. So let's say Jupiter's rings. Add ring. Boom. Yep, finally got Jupiter's ring. And let's get Saturn in. Let's get Saturn in the loose. And don't forget to put a ring. So we just have to add ring. Yep, we got the ring in. So now we got Jupiter and Saturn, and let's see if we could turn down its orbital velocity to 0, and let's see what'll happen. So oh my God, look at that. The rings are just getting maybe all the tidal force has been messing around with the ring. Boom, 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 boom. And it's gonna get a little glitchy. It's supposed to create a little more. But anyways, this is only alpha. Understand this. And just the rings are just getting flung all over the place. You can see it looks so cool. Look at all these trails, and just that Jupiter just glows. It turns up. And guess what we made? We just made two ring systems. One over here and one that is more tilted and eccentric and more I mean like more elliptical. So let's turn up the time frame. Let's see what will happen if over like years has elapsed. Maybe all the years, all the rings are gone. So and now we just got the original texture again. So they still have to work on this feature of actually alternating the texture of Jupiter. So whenever time, let's say a gas giant or anything actually hits this hits Jupiter. Let's say that. So yeah, let's see what'll happen if you put like let's say Sirius. We're Sirius. Let's get them actually colliding with each other, or maybe let's see what'll happen if you actually get them to be binary stars and get Earth to be certain binary stars. Let's see what'll happen to the solar system. Oh my God! Oh my God! Look at this. The lag is real. Now we just got this big old ugly nebula again. It's supposed to fuse. So this is totally unrealistic. So when you combine their masses together, supposed to not create a huge significant nebula with a remnant in the center. So that's the thing. So let's make years actually elapse until the nebula actually fades. Then we can continue to see what will happen. Oh, it's taking a long time. Alright, finally. And then the lag, it's just real. And the thing is, the Earth and everything has been flung away from the center of the solar system. So now we just end up with this little ugly point here. And let's see what's in the center. Looks more like yeah, we just got a little spark in the center. That's the ugly thing that happens when you collide Sirius and the sun together. That's the thing. So we just scattered the asteroid belt and the Kuiper belt, so it looks more like a cloud, dispersing outwards like a rocky nebula. So that's the thing. So let's just reset. So now we just get this perfect solar system again. And lastly, let's deploy a black hole. So let's see if we so if you make it like 2 weeks per second, let's see what'll happen if you deploy the black hole compare like let's say if you compare the black hole in the center of the solar system, no, the center of the Milky Way, which is Sagittarius A, compared to the sun, not that big, so it will actually fit in the solar system well in. So let's see. Wow, this is just really fast. So yeah, look at that, all that sucking everything in. Just looks more like a gun in space, with all the planets and asteroids like its ammo, and in the black hole as its processor, going. Oh, and now we just got the sun coming in the speed of light. Look at that. The sun hasn't probably survived that. Maybe. But the thing is, I tried setting it to real time. So when you set it to real time, then you'll see the sun actually gets engulfed in the black hole. So now we can see that the sun has been flung into deep space. So that's the thing. That so it's getting bigger and bigger and bigger. Wow. So let's reset and let's see. Let's just play around with some more stuff. We got some objects here that's like only the size of my hand to the size of my maybe let's say a basketball. So see if we all right. But anyways, so far this is one of the main stuff that are in Universe Sandbox, and sometimes you can even edit the properties. You can edit the properties in the body itself. Like you can adjust its let's say its surface temperature to where is it? All right, here. So let's say 3,000. Or maybe you can set it to 30,000, which is a temperature of a class O star. So now we got this, and always increase its luminosity to like let's say 1,000. Boom, and let's see what'll happen to Earth. Maybe. Wow! Look! Wow! Oh my God! Look what happened to Earth. It's getting burnt by the heat of the sun. Because the sun is just too big and then too hot that it'll just melt everything, and definitely no life forms can actually survive inside this planet. So it's clocks in about like 1,300 degrees C. So it's that's hot enough for like well above the drape point. So anyways, thanks for watching, guys. If you want to see what I'm doing, follow me on Instagram. You'll see, so you can just type in Matthew M. That's my name. So so please rate, comment, and subscribe, and be sure to stay tuned on more of my videos. And once again, I'm dealing with a lot of homework, so I just couldn't upload a lot of videos so far. So, but the thing is, for my grades and for my future. So do your homework.